Hello, everyone, and welcome to the online viewing session for January 6th, 2024, which reminds me, of course, Happy New Year. It's all New Year, and this is our very first activity of the new year, the first of many. And of course, a lot of them are going to occur within the first 3 months because not only do we have a great clear night tonight in Arizona, but we have, of course, a total solar eclipse coming up on April 8th, 2024, and a lot of our programming is going to be geared toward that. So we have many, many exciting things on the horizon. But of course, tonight we have, again, as I mentioned, a very nice clear night in southeastern Arizona. The only minor issue later on could be the wind, because as many of you know, those of you that have attended before, the wind is kind of our nemesis out there. But for the most part, for the sessions we've had so far this season, the wind's been pretty good. But let's do a quick recap. For the November session, we had a little trouble with the Takahashi. The filter wheel came a little bit loose. And then in December, we had a problem with the host who was really sick, but he's feeling much better now. And tonight, I think everything is fully operational. We even discovered we had a computer issue that was really slowing the computer down, which you may have noticed a bit. And I think we have that problem cured tonight. So everything is fully functional. And so we should have a great night. So without further ado, let's just jump right into it here. Let me go back to share the title slide here. So again, welcome to the online viewing session for January 6, 2024. And of course, we come to you from Arizona Sky Village, located in the southeast part of Arizona. And one of the many observatories at Arizona Sky Village is this one shown here called Piishi Observatory. Piishi is now I forget, Navajo or Apache. It's one of those for Nighthawk. So it's basically an English Nighthawk Observatory, but we like the Piishi name. And as you can see, it's a roll-off roof observatory that measures 20 by 20, and you can just kind of see the remote telescope peeking up there. Let me turn on my laser pointer, which I always forget to do. It's here somewhere. Here it is. So there we go. So there's the remote telescope peeping up there. And you can see this is our anemometer, which, as I mentioned, might be busy later because the wind might kick up. But right now it's very calm. We'll check in on that later. And then we have this little device here, this little box. And as you might know, that is our S-Big All-Sky 340C color all-sky camera. They no longer make these, but we still use ours, and it's a really good camera. It mainly allows us to, check what the weather is actually like in southeast Arizona, because sometimes the satellite view is difficult to use, especially at night when you got to switch to infrared. But let's check on what the all-sky camera is doing right now. So let me switch the screen here. I'm on the wrong thing on the web browser. There we go. So there we go. Here's the current view from Arizona Sky Village, right on the back end there of Piishi Observatory. And this kind of elongated thing on the right, that's the roof. And you can see we do have red lights in the observatory. They're not really this bright there, but this, this is like a 1 minute exposure here. But you can see the light from the observatory shining up on the open roof there. And you can see the thing just reloaded, because we do have the camera reload every 4 minutes because it takes an image every 4 minutes. But the reload of the browser and the reload of the camera or the new image from the camera aren't precisely synced unless you get really, really lucky. But that never happens. And you can see it's not quite fully dark yet. It's pretty much fully dark, but we do see this really big glow here. That's maybe the first thing that catches your eye there. And this is our first look at this season. This is the zodiacal light. This is basically dust in the plane of the solar system reflecting sunlight. And you can really only enjoy the zodiacal light from very dark areas like Arizona Sky Village. And we used to think, and many still think, that this dust is from asteroids and comets and stuff like that. But there was some more recent data in the past few years that suggests it's actually from Mars, which is difficult to explain. Now, how does this dust get off Mars and then into the plane of the solar system? And we're not really quite sure of that yet. But that was one of the discoveries from one of our orbiting spacecraft around Mars right now. I believe it's called Maven, and that Mars sheds off a lot of dust, and that ends up in the plane of the solar system and reflects sunlight as we're seeing here. And you can't quite see it on this view here, but it was extending nearly up to this bright point there, which is Jupiter. And yes, it is January. We're well into winter now. Fall is even behind us. So we pretty much have lost the summer triangle. I believe this is Deneb right here. You can see the camera's still a little noisy from the day, but it'll get better here soon. But we have Deneb, which is the brightest star in Cygnus the Swan, which is part of the summer triangle. And of course, that's pretty much long gone. But what we also have is this square here. That's the Great Square in Pegasus. And so this is the bottom, or really the top of the horse. This is the horse's back where the wing kind of comes out here somewhere. And then there's like a little triangle for the head down here somewhere, and like a leg here and a leg here. And then this star here is Alpheratz, which is the head of Andromeda. And Andromeda is like two arcs of stars. And this little tiny smudge right there is the Andromeda Galaxy. But we're not going to check out the Andromeda Galaxy tonight. We did that back in November. And then with all the fall constellations in this area here, we do have the winter constellations over here. You can see there is a little bit of a sky glow from some light pollution source out there somewhere. But again, this is a 1 minute exposure, so it looks a lot worse than it really is. I mean, when you're there, you know it's dark. And so we can see, of course, very prominently Orion the Hunter. We have the 3 stars in a row, 2 above and 2 below. The 3 stars in a row is his belt. The 2 above are his shoulders. The 2 below are his legs. He has a little tiny head, and he has his belt there where we have some pretty cool targets. And we'll be looking at one target here just off the belt toward the end of the night. And we can use the belt to kind of go upward. And that kind of takes us toward Aldebaran here, this bright star right there, which looks like it's in this V-shaped cluster called the Hyades. But Aldebaran is actually, I think, in the background, because the Hyades is like the nearest open cluster to us. We should do this one of these years because it doesn't quite fit in the view of our wide field telescope, the Takahashi. It's so big, even the Takahashi can't take in the whole thing. But we continue along our line here. We go past the Hyades and off to the Pleiades here. And we will be looking at the Pleiades tonight with the Takahashi. That's one of the targets we do every year because it's awesome. And then we reload the camera. And you can see some light source from someplace way off in the village there. And we see this little house-shaped constellation up here. And that is Auriga the Charioteer. There's like a chariot here, this L-shaped here with kind of like chariot wheel there. And then we have Capella, the goat star. And then there's a few stars in a triangle here called the Kids. And this is supposed to be the head of the charioteer. And then we have the twin stars, Castor and Pollux, but you can see Pollux is the brighter of the two. And they're actually 2 stick figures. You can kind of see Pollux. There's like a little arm. He has like a little arm here, a little arm there. This kind of long or short body and long legs, while Castor has an arm here and an arm here. They're holding hands. And he has kind of a longer body but short little stubby legs. So you can see 2 stick figures there rising up. And just now coming up above this other observatory here, I believe it's a small dome, we go down to the left, and yep, that takes us to Sirius, which is the brightest star in the night sky. And we'll check back in on the constellations here from time to time. In fact, I see a little streak there. It could be, it looks like a satellite. It's so even in brightness. And that's right near the constellation Cassiopeia. We can take a quick view here of the other all-sky camera that's online at Arizona Sky Village. And this belongs to David Churchill. And he several months back he upgraded his all sky camera, and we're thinking of doing something very similar to what he did here in the future, because boy, his image is much clearer than ours. The only kind of negative part, at least for us, for our purposes, there's these two big domes in the way. Who needs two big domes in the way? But you can really see the zodiacal light a lot better here. And I can even see there's one more summer constellation. There's Delphinus right there. So there we go. There's the current sky as we have it above Arizona Sky Village. So we're going to start, as always, with our Takahashi FSQ 106 EDX3, which is a 4-inch refractor with a Nightcrawler 2 focuser upgrade we did last season. And man, that is a really, really nice focuser. And the Takahashi is a great scope. It'll be even better when we finally get it collimated, because it does need some collimation. And currently, this device here called the flip flap is open. And you can see on back of the Takahashi here, we have our camera and the filter wheel, and the camera is a SBIG STX 16803 CCD camera. You know, CCDs, as I always mention, are becoming more and more obsolete today. CMOS cameras are taking over. They're cheaper, and they've put so much research into them, you know, thanks to smartphones and stuff like that, that they're getting to be very clean images, very low noise. And so we very well may upgrade here in the future in terms of the imaging chip, but it will probably be a bit of a downgrade in terms of electronics, because this thing has fantastic electronics. And, you know, some of the newer cameras that are more affordable, you can't get them down to the desired temperature when it gets warmer. But with this camera, with its excellent electronics, it can be 90 degrees. And believe me, I've imaged when it's up in the 90s up there. I've always been able to get this thing down to minus 20 degrees Celsius, because again, the electronics are just awesome. And so let me show you a view from inside the observatory. There we go. So here we go. This is a live view from inside Piishi Observatory. And here we see a couple of Mike Patton's telescopes. He has a 7-inch refractor over here on a plane wave mount, and there's another plane wave mount over here. And you can't quite see the telescope from this angle, but it's a 14-inch Schmidt Cassegrain. And of course, here is our setup. Of course, we have our mount, our main telescope, the plane wave, 20-inch plane wave, and then you can see the Takahashi riding on the back there. So that is a live view of the Takahashi. And you'll notice if you did join us in November or December, the angle of the view has changed, because Mike Patton was kind enough to relocate the FOSCAM, because previously this big old refractor kind of got in the way and we couldn't see the Takahashi at all. But now we got a very nice view there. But while we're looking at it, we're going to turn off the infrared light there, because that does get in the way. There we go. And hopefully Mike Patton will turn off the lights there in the warm room too. We need it nice and dark in there, Mike. I know he's listening, so lights out, Mike. All right, so let's go to this view here. This is ACP, called the Astronomer's Control Panel. And you can see I'm just on my regular web browser here. And that's all we need to remotely control the telescope. So you don't need to really install any special software from far away to control this thing. So that's what makes it so easy for our members to use. And I already have our first target all dialed in. And I'm going to hit Acquire Image. And while we're doing that, I'm going to switch back here and introduce our first target of the night. So our very first target of the night is IC 1848, the Sol Nebula. But actually, IC48 is the designation used for the open cluster that's embedded within the nebula. But you'll find for a lot of these popular nebulae that have become very popular in more recent days, because, you know, more recent years, because they're so easy to image with today's cameras. So oftentimes because a lot of these fainter nebulae have more obscure designations. We kind of steal the more common of the two, and of the main, there's the big three deep sky catalogs. There's of course the Messier catalog, the NGC catalog, and then there's the Index catalog or the IC catalog. So this is one of those IC objects, and again, the specific one here is the open cluster, but because there's a much more famous nebula surrounding it, that's what we use the designation for. So the nebula is formally designated as Westerhout 5 or Sharpless 2-199 or LINS 667. And that's from LINS catalog of bright nebulae compiled in the 1960s by Beverly Lins. And there are several small open clusters that are embedded in the nebula. These include CR 33, 34 plus 632 and 634, which are more obscure. And then there's IC 1848, which is kind of in the main part of the nebula. And there is a small emission nebula called IC 1878 found on the top of the head. But I'm kind of getting ahead of here myself. Let's show the general location of this object in the sky. So it's technically in the constellation Cassiopeia, but it's like right on the border with a neighboring constellation, much more obscure, called Camelopardalis, which really means the camel leopard. But before the word giraffe came along, they called those animals camel leopards. So Camelopardalis is the giraffe, the modern day giraffe. And this is a very, very faint, hard constellation to find. So this is the general area that we're looking at. And here's where I should have been earlier. Here's a more detailed view, which I took from Sky Telescope's Pocket Sky Atlas, which I highly recommend. I'll show you a copy here later. So again, you can see there are several other catalog or clusters nearby. I mentioned CR 33 and CR 34. You can see those within the nebula here. There's IC 1848, which again is the body of the Sol Nebula, also known as the Fetus Nebula, I believe, because you'll see why we call it that later. And there are other objects that aren't shown that I did briefly mention, so we won't bother to mention them again. And you can see we're in more familiar company here. We do see this is the tip of the constellation Perseus, which looks like a wishbone. This over here is kind of the end of Cassiopeia, and there's the famous double cluster. So this gives us a really, really good idea of where we are in the sky. And I can hear some dinging in the background there, so let's switch to one more view here and see how we're doing. So this is the computer in the warm room of the observatory. So this is the computer that we're connected to, at least that I'm connected to via the web. And this is the computer that does control the telescope. It's directly connected to the telescope. And we can see again, the wind is staying calm. That's the main thing I wanted to check here is the wind is only about 3 miles per hour, which is a lot lower than it was forecast to be. So that's a good sign. And this little box here shows the star that we use for guiding, because no equatorial mount is perfect. Well, maybe some are if you spend an ungodly amount of money. They're getting to where they're nearly perfect now if you have what's called absolute encoders, but we don't have those because they are very expensive. And you can see we do have a guide star to compensate for minor guiding errors of our paramount. And we have already begun the image of our target, the Sol Nebula. And you can see over here we have Focus Max, which I used to focus the telescopes earlier. But we're not going to do that during the session, so we'll just kind of collapse that, make that go away. And what we have open here, this window here where we're doing our guiding, this is a program called Maxim DL, which we're kind of required to use with ACP. If you use ACP, you got to use Maxim, which is kind of a drawback these days because there's lots of newer, better stuff coming out all the time. And of course, this little window here is ACP itself. So you can see my name here because I'm connected to ACP from my web browser at home. And we do have our clarity station that I peeked at earlier. The wind is pretty good. It's rather humid for out there. For 48% is pretty humid for out there. There are times I've used the telescope where it's read, practically zero, like 1-2% humidity, which is awesome. You just walk outside and you're like, you're you're sucked dry. It's so dry out there. And then we have M1 Oasis, which is what we use to control the roof. So the roof, of course, is rolled off. All righty. So let's go ahead and stop sharing there. And I'm going to finally let you unmute yourself because we're just under, our exposure is underway. We're doing a 10-minute exposure of the Sol Nebula, and we're probably within the first couple of minutes now. So we have a little bit of time to kill. So if anyone wants to just say hi, tell us where you're from, either verbally or in the chat, or ask a question about the telescope, the cameras, the mount, astronomy in general, the Kalamazoo Astronomical Society. I can't give you any stock advice because I'm terrible with stuff like that. So don't ask me. You'll go broke in minutes. But I'll try to answer just about anything you got. So welcome, everyone. And I should mention these sessions are much more fun when people are interactive.
Hey, Richard, I've got hotel reservations for April 7th and 8th in Ohio, so we can go down and see the eclipse.
Well, good luck with that.
Well, I can't drive to Texas, so we're going to go to Ohio.
Okay. I hope it works out for everybody.
Well, that's what I'm planning. Thank you.
So I do see some folks from Tampa and Loveland. That's great. So did anybody get any astronomical goodies for the holidays? Me either. Oh, we got some folks from Peoria. That's nice. Welcome. Yes, definitely take your 8-year-old out of school. That's totally good. Don't absolutely do that. So yep, we got people from all over the country. Well, let's check in to see how we're doing here. Everyone's going to be very quiet again, I can see. So let's go back to ACP. We'll scroll back up here and we'll see how we're doing. It does look a little choppy. The scene was forecast to be kind of blah tonight, so we can't really do anything about that. And you can see the previous thing we imaged in the window here. This is actually something I'm working on here. It doesn't look like much, but this is a sulfur 2 image of the Rosette Nebula. Yes, there is a nebula in there, but with sulfur, it doesn't turn up very much. But this is a long-term project I'm working on. You can see maybe a little bit of nebulosity here, but in sulfur 2, it's pretty non-existent. So that's what I'm working on. It's been a while though, because the weather's been a little rough out there. And it usually is that time this time of year. All right, so we're a little over halfway done. And again, we are imaging IC 1848. We're doing a 10-minute exposure with the hydrogen alpha filter because that sucker really pops in hydrogen alpha. And we can go back to the view here. I don't really want to turn the infrared camera on, unfortunately, because that might mess up this picture, but trust me, it's pointed pretty high. And it's gathering photons as we speak. Okay, zoom controls, go away. Well, we'll just stop sharing there. Sometimes those zoom controls just don't go away. Oh, we have one Canadian at least from Montreal. Welcome. Oh, Jack, you are going to go to the Armstrong Air and Space Museum, huh? In Wapakoneta?
That's the plan.
That's my one of my backup areas. I kind of have a third option in Arkansas too that I was looking at.
Well, I thought as long as we go down there, and that's almost on the center line, it's like 3 minutes and 58 seconds of totality.
From Kalamazoo, Wapakoneta is about the closest place you can drive to.
Yeah, that's about it. Yeah.
Oh, great. We do have people from New Hampshire and Newburgh, Oregon, Lansing, Michigan. That's not too far away. Another from Maryland, where it's rainy and cold, but yeah, it's today here it was cold and gray and gloomy and some flakes of snow in the sky. But thanks to oh gosh, which one is it? La Nina or El Nino? It's one of those. You know, we're not getting much in the way of snow this season so far. Yeah, I heard you folks are expecting a blizzard out there. Better you than us. Sorry, but it's true.
Yeah. It's our first one this year. Not too bad.
If I was there, I'd help you shovel.
Do you all have any connection with Arizona State University's astronomy program?
We do not.
Just wondering. They have a way for undergraduates to do research using either a Hubble Space Telescope or the James Webb Space Telescope.
Mm-hmm.
So,
there we go.
should be fun.
All right, we're almost done with the exposure there. Maybe about a minute or so left. And of course, when we bring up the image, hopefully it'll pop up a lot faster this time. Everyone go ahead and unmute yourself because we like to get the natural reaction when the image pops up, especially the first one. We like to hear those oohs and ahs out there. And you can see the weather over here. For some reason, it tells you the wind speed in knots because I don't know why Bob Denny did that. Bob Denny's the guy that created ACP because, you know, it's an observatory. It's not a freaking sailboat. We don't need to know the wind in knots. I want, you know, even kilometers per hour would be preferable to knots. But if it gets up to 9 knots, that's about 10 miles per hour, and that's when it gets really shaky. But I have the alert system set for 20 miles per hour because I don't want the system to suddenly just shut down on us. And there's a buzzer, and with the headphones on, that buzzer will make me go deaf for the next probably hour or so. So I'd prefer not to hear that because it's loud. All right, our exposure is complete, and for some reason ACP always tends to go like a few seconds past. Oh, I know why the controls aren't going away. Because the chat. People are putting stuff in the chat. So the window stays open. Oh, there we go. Let's see how fast it processes this time. It should be pretty quick. Now that we found what was slowing down the computer. There we go. Ooh, pretty.
Ooh.
Hopefully the actual image looks better or as good. Sometimes the thumbnail looks better than the actual picture. So I'm waiting to hear some gonks, some bongs in my ear piece here, my headphone, because that tells me the image is processed. Because what happens is the image downloads from the camera, and then Maxim creates a quick thumbnail here that we see, and then it processes the larger view, which it then shrinks down a bit. And now the observation has been complete. All right, are we ready for the first image of the night?
Yeah.
Yes.
All right, here we go. IC 1848, the Sol Nebula. Ta-da!
Ooh.
Yeah, that's what I'm talking about.
We'll scroll down here a little bit. So you can see why it also has the name, the Fetus Nebula, because yes, it does look like a fetus.
Nice.
It looks like a pretzel.
That's more its neighbor definitely does, the Heart Nebula, which we can see down here. This is part of the Heart Nebula, and that does kind of look very pretzel-y. We did the Heart Nebula last year, so I figured we'd do the Soul Nebula this year. So there it is. So the Heart and Soul together span an area of about 300 light years. So both the Heart and the Soul, they're part of the same nebulosity. And again, together, they are 300 light years across. While the Soul Nebula along the long axis here, that's about 100 light years. So that's pretty big itself. That's still bigger than the Orion Nebula. And so because emission nebulae like this are regions of star formation, the stars here are very young. You know, they're practically brand new. So we're very certain that stars in this region are less than a few million years old. And like all nebulae, they are shaped by the stellar winds from stars embedded within it. And this object is home to what's called W5, a radio source that spans an area the size of four full moons. So if we had eyes the size of wagon wheels, the Soul Nebula would look quite a bit different. And the radio source has large cavities that are the result of nearby massive stars' wind and radiation that carve out the nebula, pushing the gas together and causing it to ignite and form new stars, which is a process we call self-sustaining star formation. You know, a nice massive hot star forms in this nebula, and its solar wind and ultraviolet light push the gas around that helps create more star formation. So studies have shown that the stars are progressively and systematically younger the more distant they are from the center of these cavities. So a little bit of science background on the Soul Nebula for you. But otherwise, it's just your cool looking run-of-the-mill emission nebula that looks like a fetus, and it looks like it took a little poop right there. There we go. You can call this the Poop Nebula. You can quote me on that. Or if you want to be a little more polite, the Dropping Nebula. There we go. But that's a great target. And when you get these images, they'll be a little better processed than even what you see here, because this is the quick job that Maxim DL did. And you'll also have the full resolution version, so you can zoom in a little bit closer. And of course, we'll give you the link for those at the end of the night if you didn't get it already, if you're not a member or you're not on the online viewing session email list. So there we go. The Soul Nebula. All right, let's go to our next target. Everyone knows our next target, I'm sure. We're going to put in an M there, 45. And we're going to hit get coordinates because I often forget. We're going to change it to about, I think, we'll go ahead and do 5 minutes. Even that's kind of on the long side. But what the heck? And then we'll hit acquire image. And off it goes. So if you're not familiar, M45 is none other than the Pleiades itself, which is referred to as the Seven Sisters, after the 7 doves that carried ambrosia to the infant Zeus, or to the 7 sisters who were placed in the heavens so they might forget their grief over the fate of their father, Atlas, and condemned to support the sky on his shoulders. So it is called the Seven Sisters, but most people with their unaided eye can see about 6 stars easily. But if you're under dark skies and have good eyesight and really spend some time on this, you know, breathe, oxygenate your blood, I'll say that better next time, and you can see maybe more than 7. In fact, there are 10 stars that are brighter than 6 magnitude in the cluster. So you should theoretically, if you have good eyesight, be able to see up to 6. But the famed visual observer, Stephen James O'Mara, who is also a very good author, he once logged 17 Pleiades, which is what we call members of the Pleiades, from Cambridge, Massachusetts. So if he can do it from light-polluted Cambridge, people should be able to see a lot more than 6 stars from anywhere. So again, he got 17 stars with just his eyes alone in this little area of the sky. And quite oftentimes, based on the shape here, it's been referred to or mistaken for the Little Dipper, because it does look like a Little Dipper in the sky, but the Little Dipper is actually even much bigger than the Pleiades. So you can think of this as really the Mini Dipper. We got the Mini Dipper, the Little Dipper, and the Big Dipper. So this has been known since ancient times in cultures across the world, including China, Japan, Persia, Maya, from the Cherokee, Aztec, Sioux, and the Aborigines, because it's just an obvious target in the sky. And of course, the Japanese mentioned it as Mitsubishi, which means 6 stars in documents dating back to the 8th century. And they also are known as Subaru, which means coming together or cluster. And of course, there's a car line named after the cluster, which has a little star cluster for its logo. And it has been mentioned in the Iliad, Homer's Odyssey, the Bible, and the Quran, amongst other texts. So, of course, it's been known about for a very long time because it's a very obvious target in the sky. The Sol Nebula is a little more obscure, but the Pleiades, of course, is very, very common. You can observe it with your eyes, binoculars, and telescopes. And it's easy to find just on the back of Taurus the Bull here. Here we have Taurus the Bull. Again, there's Aldebaran with the Hyades, and we see the Pleiades right in the center of the target there. And here's a better view with SkyEye Telescope's Pocket Sky Atlas, where you can see a little more detail. But one of the bonus pages in SkyEye Telescope's Pocket Sky Atlas is kind of a more detailed view of the Pleiades shown here. So we'll get to see all this. We'll get to see the Merope Nebula, the Maya Nebula, and the Alcyone Nebula, and even the nebulosity around the star Electra. And then we'll see this little line of stars here, which I always like to see in binoculars or a telescope. And for many, many years, I've been trying to get people to call this the Bell string. The fact that my last name is Bell is, of course, just a coincidence. But to me, it looks like a bell string. So please, when you refer to this or share it with the public, call it the Bell string. It'll make me happy. I mean, I do so much. That's the least you folks can do. All right, so let's see how we're doing. Let's go back to ACP. We already have a guide star, and our image is well underway. So we're doing good. And again, the guiding's a little choppy tonight because, yeah, the scene's a little on the rough side. So let's see. Let's check the all sky camera. You can see the zodiacal light is fading as the sun gets lower and lower in the sky. Nothing notable, though. I noticed the neighbor, for those of you that especially joined us in November, he had this annoying red light. But he doesn't even have his house lights on. Maybe he's not even in town because the place has looked quiet for a while. And here's David Churchill's view. Nothing too special going on there, which is good. No clouds, but no bright meteors either. That'd be more fun. And there we go. All right, well, we'll check back in here in a minute. I think I saw a question pop up in the chat there. So what is my opinion on the Celestron Nexstar 8SE? Worth it, or is there one better? I don't know. For a visual scope, I think the Nexstar 8SE is a really good telescope. It's definitely not for astrophotography. You could definitely try using it with that, but it's a great visual scope. So I certainly don't have any objections against it. They've been making the 8-inch optical tube for many, many years. So they pretty much got it down to perfection. So pretty much any 8-inch you got will be visually superb. And I know the Nexstars, they're very quiet. We used to joke that the Meade telescopes, I'm not sure how good they are now, but back when I had my old 10-inch LX200, it was like the coffee grinder effect. You can wake the dead with that thing. They can be so loud, but the Nexstars were very quiet. I used to sell telescopes, and I remember when I first got the Nexstar 11 in for the first time, when they first came out, I thought it was broken because, you know, it moved, but the thing was so quiet. I was like, it's got to be broken because it's so quiet. That thing was really, really quiet. But yeah, I think it's a fine telescope. So if you definitely want the go-to, that's a good one to get. You're welcome. Well, let's go ahead and go back to the ACP here, see some action. We're almost there. We're only doing like I said, we're only doing a 5-minute exposure of this one because it's already pretty bright. Even 5 minutes will be a little overkill, but it shouldn't be that bad. You can see it goes 4 seconds past. It doesn't do that in Maxim, but it does it in ACP. It's so strange. Oh no, it's upside down. Of course, there is no upside down in space. If we wait for it to go on the other side of the meridian, then it'll look right side up. Or is it already on the other side of the meridian? I can't remember. So it's working in the background as we speak here. And you can see it's pretty high. We're looking at about 71 degrees above the horizon. Rounding up, of course. And let's see what it's doing. So what it does is it counts stars and does plate solving. So wow. That's a lot of stars. Okay, the image is complete. I didn't hear any gonks though. It's very quiet. Okay, are we ready? Here we go. The Pleiades. Oohs and ahs. Ooh.
Oh,
Nice. Beautiful.
Look at all that nebulosity.
Wow. That is beautiful.
it's great.
Mm.
So the Pleiades is about 100 million years old. I had my students confirm that many, many times over the years. And it's composed of hot blue, highly luminous stars that belong to mainly spectral type B. You know, there's O, B, A, F, G, K, M. So O-type stars are the hottest, and then Bs are the next. So these are some pretty hot stars. They're up there. And it contains about 100 stars in a sphere of about 15 light years in diameter. And it has a tidal radius of about 43 light years. It has a total population of over 1,000 stars, which does not include unresolved spectroscopic binaries, you know, binary systems where the two components are very close together. And it's estimated that the cluster will survive for about another 250 million years, which is pretty typical because these clusters, you know, they do not last forever. The sun was very likely once part of an open cluster. We even see evidence of supernova remnants and meteorites discovered here on Earth. So the sun was near some of these really hot, massive stars that blew up and left their signatures in meteorites. But none of these stars here will currently go supernova. The Pleiades is far too old for that. And what happens as they orbit the galaxy, they encounter dust clouds, which is what's happening to the Pleiades, externals or alien stars, and they're gradually stripped of their members, or they just die off like the more massive stars this cluster likely once had, like type O stars, because 100 million years old is too old for a type O star. So if it did have any type O stars, which I do believe it likely did, because I think we do know of some pulsars here, they are long dead. And of course, what we see here, this glow, this is called a reflection nebula. And it's around the brightest stars that was once thought to be leftover material from the cluster's formation. And when I was a student in physics at Western Michigan University, I read an article in the Astrophysical Journal that announced for the first time that the Pleiades and this dust are going in different directions. So that means they can't have a common origin. And it just so happens the Pleiades is just kind of plowing through what's known as the Taurus Auriga complex of dark nebulae, and very dark images, or not very dark, but very deep images of this region, wide field deep images. You can really literally see the Pleiades plow through this dust, and it's very likely losing members in the process. And of course, it's really impossible to see them in this view here, but the Pleiades does contain many brown dwarfs, also known as failed stars, that make up about 25% of the cluster's total population and less than 2% of the mass. So there you go. And of course, it looks like a little mini dipper. But there's a little more information about the Pleiades. And just to review, what do I call this little string of stars here? Come on, come on. Somebody say it.
Bell string.
There we go. Come on. Let's make it catch on. All right, let's go to our next target and our last for the Takahashi. We'll do another index catalog object. We'd like to do some of the obscure stuff when we can. We'll hit get coordinates there, and I think we're doing pretty good on time because this one is faint. So I think we'll keep the luminance. H alpha doesn't do anything. This is kind of another reflection nebula, but this is a cool one. And here we go. So our next target is indeed IC 2118, the Wishhead Nebula, which is about 1,000 light years away in the constellation Eridanus, the river. And I forgot to mention, I always, in these little introduction slides here, I always show a sketch from an amateur astronomer. I try to give credit when I can, but sometimes they don't credit themselves, so that makes it difficult. And you can see a very good sketch of the Wishhead Nebula here, a very talented sketch, because this target, again, it's difficult. Even this image here, 10 minutes under dark skies, it's not going to be really, really bright because it is faint. But here we see the witch upside down. So this is a pretty good preview of what the image will look like, but a little brighter stars for certain. And it's pretty big, 3 degrees long. That is 6 full moons. So this thing is big. It's a very, very big target in the sky. And at magnitude 13, it is faint. But even though it is faint, if you want to at least take a picture of it or try to find it with optical aid, it's in a pretty easy area to find. It's just off the star Rigel here in the constellation Eridanus, which is this very long, winding constellation like a young river. There we go. And then we can zoom into the close-up here. And yeah, and this kind of even gives the impression that the Wishhead Nebula is indeed upside down as we see it in the northern hemisphere. But go south of the equator and then we'll look right side up again. So the true separation between Rigel and the Wishhead is only about 40 astronomical units, which is, a little beyond where Pluto is from the sun. So it's relatively close to Rigel. And so if that's accurate, that would make the nebula about 50 light years long. It was discovered photographically by the German astronomer Max Wolf in 1909. And as I mentioned, it is very difficult to observe visually due to its large size and low surface brightness, but it can be seen with 7x50 or 10x50 binoculars from dark sites like Arizona Sky Village. So Mike, after the session's over, run out and see if you can find it and let me know. So the Wishhead Nebula was memorably used in TV and in the TV series Andromeda as site of a major space battle that sent civilization into an era of chaos. So if you've ever seen the show Andromeda, you know exactly what I'm talking about, but I haven't a clue because I've never seen it. It is, again, located in Eridanus, the river, about 2.6 degrees east of Rigel there. And we'll come back to that relationship here later. And of course, there's a very famous target here, the Orion Nebula. And if you're really anxious to do that one tonight, sorry, we're saving that one for next month. But we are going to do one up here later. Little preview. All right, so let's check in with ACP there, see how we're doing. Uh-oh. Well, that's strange. We didn't get a guide star. Huh. Well, with the Whitefield Takahashi on the Paramount, it shouldn't suffer too much. But that's strange because there are plenty of stars in the area. Well, let's take a peek at the, there's no clouds. Of course, we are looking, it's not really low either. Very curious. But again, it should look like a pretty respectable image, because the Takahashi is only 530 millimeters in focal length, and the Paramount is a very, very good tracking mount. So we should be able to still come up with a decent image. But if I was going for a very sharp astrophotograph to process later, I would stop it and try again later. Let's see how David Churchill's view is doing. See, even in this better exposure here, you can't even see where it is. I mean, this little bright streak there is the Orion Nebula, but there's no sign of the witch head here. That thing is faint. All righty. Any other comments or questions or anything? Did I miss anything in the chat? Been pretty quiet. Yes, and thank you. It is the beautiful bell string. Thank you for putting that in caps too. That's very important. Boy, I'm not sick, but my throat's still bugging me. I haven't given any lectures in a while. But I better get warmed up because we start with the lecture series next Saturday. That's going to be fun. Let's see. Let's check in the wind speed here. Let's see. Oh, I got timed out because we're using the free version. So they kick me out after so much time. It's very rude. There we go. Ugh. I don't know why I didn't pick one of these stars for a guide star. Oh well, whatever. Well, it's up to 4 miles per hour now, the wind, that is. So that's a lot less than was forecast. So I think we're going to be okay. No wind kicking up issues later. I think we're in good shape. And we'll just patiently watch the minutes tick away here. No usable stars. Look like there's some good guide stars there to me. It's not low. It's only 37.5 degrees is pretty good. Oh, well. Peek in the all sky camera. You'll notice the perch here. We installed that a couple years back because birds kept landing on the dome. Because our theory is, of course, birds want the highest vantage point to look for prey. So they kept landing on the dome and leaving little bird droppings behind, which became a constant pain to clean up. So we put in this little bird perch, and that has pretty much solved the problem. They very rarely land on the alt sky camera now. Why we have the bird perch all to one side, I don't know. We used to have it equal on both sides, but for some reason it got pushed over to one side. It's a mystery. Not too much change in the sky here. Sirius is a little higher. It's not, it was like over here, right, earlier above the dome. Now it's like over here. So some progression in the sky. Zodiacal light is still looking pretty good there. I was trying to see Cepheus earlier, but I can't spot it. The image is still a little noisy. And in David's view, it's behind the dome. So that's no good. 200 seconds to go. So earlier, our own Jack Price shared his eclipse plans, and I think a few people did in the chat, but if anybody wants to mention where they're going to see the eclipse, I'd love to hear it. Anybody else going to Texas like me? I know it's like 10 o'clock at night, at least here, but come on, folks, wake up.
We're headed to Sandusky, Ohio,
Okay.
to the lakeshore,
Oh, okay.
and hope that the winds will blow all the clouds away.
I hope so. Where in Texas? Okay, so we're going, a group of members are going to Chalk Bluff. It's called Chalk Bluff River Resort and Park. I can mention that now because the place is booked solid. So I didn't tell anyone that before because I was hoping members would take up all the bookings, which we partly did, not mostly, but partly. So that's in Uvalde County, where I see Sherry is going. But I do have backups, like I mentioned, if it is, because if you look at the satellite view from past April 8th, usually when it's cloudy in Texas, it's like clear in Ohio or something like that. But when it's cloudy in Ohio, it's clear in Texas. Very rarely is it clear in the same place at the same time. So this is going to be a difficult one compared to the August 2017 eclipse. I watched the weather, of course, but I never worried about it because I knew in Wyoming, where I was, we weren't going to have any major issues, and we didn't. All right, we're almost done there. But I hope many of you are planning on to join us for the Eclipse series, which is ongoing. We've already had 3 installments, 2 of which are currently on our YouTube channel. The third part from Alan Dyer about processing eclipse images, that comes out on Monday, by the way, so look for that on our YouTube channel. And then the next installment is this coming Friday, where we'll have Jay Anderson here in Kalamazoo. So we're very much looking forward to that. He's a very well-known eclipse chaser. All right, we're done. There's the thumbnail. Oh, it looks like it's right side up too. That's nice. See a bit of glare from Rigel. We don't always get that. Mike Patton, who owns the observatory, did mention it looked a little hazy to him. So maybe we're getting a little haze there from, which is causing the glare from Rigel. But the images aren't terribly suffering from it. And if it is kind of hazy, that could make it difficult to get guide stars because we guide in the infrared with our on-axis guider, because that only lets through infrared light, and that would be a little more susceptible to haze. So that could be why we didn't get a guide star. All right, are we ready?
Yes.
Dump, 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 dump. There she is.
Oh.
Ah,
Nice.
Hello, my pretty. Ding dong, the witch is dead. All right, I'll spare you folks from my musical rendition there. I just watched Wizard of Oz for the first time in probably 30 years on TV recently, so that's why I got it fresh in my head. So there she is. She's pretty much from the top of her hat to the tippy of her chin there. That's her right there. And that, of course, is Rigel right there. So we're looking at it upside down as we see it in the sky. So IC 2118 is a reflection nebula. And like the Pleiades, if this were a color view, it would look blue. And it's produced by starlight from Rigel, reflecting off dust particles in the interstellar medium. The blue color, and just like with the Pleiades, indicates the dust particles must be very small in order to preferentially scatter the short wavelength blue photons or blue light. So the longer red light just goes right by the dust particles, but the little bitty wavelength of blue gets scattered off. And this could be, we don't really know what its origin is, but it may be an ancient supernova. Radio observations have revealed that parts of this nebula show significant amounts of carbon monoxide emission, indicating that it contains molecular clouds where star formation occurs, which would be, unusual for a reflection nebula, but maybe it's past its, maybe it used to be a more prominent emission nebula, but it could have been a supernova around it too. And there are candidates for pre-main sequence stars that have been detected, very young stars just beginning their lives, as well as some T Tauri stars embedded deep within the nebula. So this definitely could have been a former site of star formation, but the fact that it's just a reflection nebula tells us today it's probably pretty much not. And it does have a total mass of about 85 suns. So all this is about 85 of our stars, the sun. And we can scroll down a bit. Nothing too much notable in there. Just a bunch of stars, but they're very pretty. So there we go. Our last target for the Takahashi tonight, IC 2118, the Witch Head Nebula.
Richard,
Yes.
if you go straight up from Rigel, almost near the top, it looks like there's a spiral galaxy up there.
Up here?
Let's see.
Nothing that jumps out at me.
No, wait a minute. What's the bright one off? Is that Rigel right next to the nebula, the bright one?
This big glare is from Rigel right here.
No, the other side then. I'm wrong.
Yeah, I'm not sure what the glare from here is. This is probably just
The
some
bright star just to the left of the nebulosity.
Oh, here, yeah.
And then you go almost up near the top.
I see there's a little galaxy there. That's definitely a galaxy right there.
Yep.
Yep.
I think that's the one.
That's
Yep,
it.
that's the one I thought I saw. I wasn't sure if that was it or just a distortion of the pixels.
Nope, that's definitely a galaxy. All righty. So now what we're going to do, before I forget, because I always forget, so I'm going to do it while I'm thinking about it. I'm going to go into ACP here and change it back for the plane wave, because if I don't have the proper aperture and focal length in, the pointing will suffer a bit for plate solving later. There we go. Aperture is 508 millimeters, which is 20 inches, and 3,454 millimeter focal length. That sounds good. So let's hit OK there. And now we'll go back to, I'm doing this the long way. We'll go back to ACP, and we're going to scroll down here and hit this one. We're going to switch from the Takahashi to the plane wave, and it should, there we go. So we're going to switch telescopes here, obviously. We're going to switch to the big one, the plane wave CDK 20, which is our 20-inch corrected dull Kirkham telescope. You can read this now or later why it's a dull Kirkham telescope. What makes it corrective is there's a lens in the back that helps adjust the image, but we won't get into that. So the Takahashi has a 4-inch aperture, while the plane wave is 20 inches. So much bigger aperture, much longer focal length. We could not do the witch head with this thing because it is far, far too big, unless we do a huge, huge mosaic, which we don't certainly have time for tonight. So on the back here, we have the same exact model camera that we use on the Takahashi, which has caused its issues in the past, having 2 of the same camera and the same system. We're going to fix that when we eventually switch off to CMOS cameras here in the future. And we have the same filter wheel with the same set of filters. We have luminance, red, green, blue, hydrogen alpha, oxygen 3, and sulfur 2, all 7. This is a 7 filter wheel. We have all 7 filter slots taken. And I mentioned we have an on-axis guider that guides in the infrared. And there's our current auto guider. It's not the first one, but it's our current one. So that is the imaging train of the big scope. And of course, everything, plane wave, Takahashi cameras, it all rides on the massive software BISC Paramount ME2, which has a 240-pound capacity. And we're nowhere near upwards of that. One of these days, we got to rearrange the counterweights because the heavy one's supposed to be toward the center of the mount, but we'll fix that in the future. Hasn't really caused any obvious issues though, so we're good there. But there's our mount. But I've mentioned all this many, many times before, and you're welcome to read this if you're not familiar with it. All right, I believe I heard everything complete there. Looks like we're good to go. We have, yes, we've switched to the plane wave. So let's go to our first target, NGC 891. And let's knock down the time here. 10 minutes should be adequate. And there we go. Make sure I did hit it. Yep. Sometimes I thought I hit it in the past, but I did not. So I figured we got to do one galaxy tonight. And that's going to be NGC 891, the Silver Sliver Galaxy. Try saying that really fast. Silver Sliver Galaxy. And if you're really into the Caldwell catalog from Sir Patrick Caldwell Moore, the late Sir Patrick Caldwell Moore, this is entry number 23 in the Caldwell catalog. Stephen James O'Meara, who we mentioned earlier, nicknamed it the Outer Limits Galaxy because it's featured in the series premiere episode of The Galaxy Bean in 1963, which I've never seen that show either. But I mentioned these things. And this is another target that I'm sure many of us that have been observing for years have observed this many times, especially me, because as some of you might know, I love me some edge-on galaxies. They're just so different and exotic. So this is easy to see in an 8-inch or 10-inch scope. And but you need really 13 inches to detect the dust lane more clearly, maybe with averted vision or not if you have really good eyesight. It was discovered by William Herschel on October 6, 1784, and the discovery is often incorrectly attributed to his sister Caroline. She certainly had her great discoveries like NGC 253 that we looked at back in November, but this galaxy is not one of those. So Herschel described it as considerably bright, much extended, above 15 arc minutes long, 3 arc minutes broad, a black division, 3 or 4 arc minutes long in the middle. And of course, back then, he didn't know what galaxies were. It is located in the constellation Andromeda. And you can see it's just off the end of the arc here from Almach. This is Almach, or Gamma Andromeda. Very nice double star too, by the way, which received a lot of notice back in April of 1997 when Hale-Bopp was like right next to it. So here we go. That's where 891 is roughly located amongst the stars of the sky, kind of between Andromeda and Perseus there. But of course, here's the more detailed view from the Pocket Sky Atlas, where again we see it about 3.5 degrees east of Gamma Andromedae, Almach right there. So it's a pretty easy object to find. You just kind of star hop off Almach and there you go. Or just pick up your phone or tablet or keypad and type in NGC 891 and off it goes. We see the very popular demon star Algol, very famous eclipsing binary with a Messier object nearby, M34. I don't believe we've ever done M34 during a session, but we'll remedy that sometime in the future. All right, and I do hear some activity in my headphones here, so let's see how we're doing. Looks like it's looking for a guide star right now. Let's we can switch to the computer. And you can see I got to resize everything now because it's switched off. Maximum and everything has to close when we switch telescopes. And we'll switch there. Well, I'll resize it later. And it looks like we're guiding. All right. Oh, there we go. The guider is settling now. There we go. Ah. There we go. This isn't really important, but what the heck. And I always like to put it down here so it gets out of the way. Ah. Of course, the computer's working, so it's being funky on me. There we go. But we're guiding. Let's see how we're doing. Yep, still guiding away. The wind is up to 3 knots now. So Evast ye matey, it's 3 knots. I don't know why it's in knots. And let's see. No new questions in the chat. That's good. Or that's too bad, really. Anybody from any other astronomy club want to introduce themselves and tell us what club you're from? Not in the chat. Come on. We're tired of the chat. I don't like the chat. I should just turn it off. So we're guiding away there. And yes, Friday's lecture is newbie friendly. It will not be a terribly technical talk at all. So absolutely join us on Friday. I'll give a little plug for that later. But, oh, what the heck we can throw in a couple of things in the chat here, which I got to open again. So, of course, if you live in the Kalamazoo area, we would love to have you in Kalamazoo Friday, January 12th, because Jay Anderson, weather permitting, will be joining us live and in person. We had him here in 2017 for our Astronomy Day event, and the crowd size was kind of disappointing. So we're looking to really make that up to him with a really big crowd during our general meeting at our regular meeting site. You know, if you do live out of the area, obviously you can join us on Zoom, but he's coming all the way from Winnipeg, Manitoba, Canada. So if you live with even an hour or two of Kalamazoo, I think it's totally worth driving to see him. If you have any of his books, for sure, you can get them signed. And we're starting the Introduction to Amateur Astronomy Lecture Series the following day. We already have over 600 people from all over the world that have registered. And I do mean all over the world. I sent out the list of countries today. We got the US, of course, Canada, the UK, Germany, Australia, Botswana, South Africa, Australia. and we'll even have a lot more come from the Philippines. So we do have people all over the world attend the Introduction to Amateur Astronomy lecture series. It is a worldwide event.
Sounds pretty cool.
It is cool.
I'll be taking the class and I'm looking forward to it. I'm a beginner.
Great. It's a perfect class for you then. It is 5 parts. Yes, go ahead.
I said, oh, same here. I wouldn't
Good.
mind taking it. I probably would be here for the last one, but do you still post them all on YouTube and everything?
They will be on YouTube. I'm still, the thing I'm struggling with is some of you know, we've been releasing stuff later and later on YouTube because we've kind of, attendance hasn't been what it should have been since the pandemic. So we think some people are either just joining us on Zoom, not coming in person, or just waiting for it to come out on YouTube. So if you just wait for it to come out on YouTube, we're going to make you wait. So for the Eclipse series, we've been waiting about a month to release videos. But for the lecture series, I'm not sure. I'm leaning toward waiting until the series is actually over to release all of them.
Okay, okay.
So I don't know, because we don't do this stuff for YouTube hits. I could care less.
Yeah.
I am not one of these YouTubers that make money off of it, or the club does. We want people to attend. Could care less about the YouTube hits. It's not like we get thousands of hits anyway. If we did, then I would care, but we only get a few hundred hits, so who cares?
All right.
All right, we're almost done here. Don't get me started. I hate the YouTube. There it is, dead in center. Thank goodness I changed the focal length. It'd still be in there, but it wouldn't be in the center. Let's see what it's doing. It's found 6,391 stars. When you download the image later, someone count those and confirm that for me. All right, are we ready? Our most distant target of the night. Here we go. Ding, there we go.
Wow.
Ooh, man.
That's really cool.
It is. I love those edge-on galaxies. And there are several other galaxies in the field too. You can see one there, probably several others. Oops. So at 89.8 degrees, it is oriented almost exactly edge-on to our line of sight. The galactic disk slices north-northeast to south-southwest for 11 arc minutes, but is less than 2 arc minutes thick at the central bulge here. So it is long, but narrow, your typical edge-on galaxy. It measures about 110 light years in diameter and has a mass of 150 billion suns, fairly comparable to the Milky Way. And like the Milky Way, it may be a barred spiral because it does kind of have an elongated central bulge. If it was very spherical, that would mean it's your run-of-the-mill regular spiral galaxy. But when they tend to have an elongated bulge, like the Milky Way does, then it tends to be a barred spiral galaxy. Usually, of course, it's very easy because you can see the bar, but when it's edge-on, you can't. So it is also similar to the Milky Way in total luminosity, bulge size, disk with prominent dust lanes, and the number of globular clusters. The Milky Way has about 150. To date, this one has about 200 known globular clusters. It is a member of the NGC 1023 group of galaxies in the local supercluster, which is what we are part of. You know, the Milky Way is part of the local group, but the local group is part of the local supercluster, known as the KAS supercluster, which contains about 14 members in its galaxy cluster. A little poorer than the Milky Way's galaxy cluster, but there are probably many fainter galaxies in this region awaiting discovery. And evidence suggests, like the Milky Way, NGC 891 is surrounded by a massive halo of dark matter. We see evidence for that around many, many, many galaxies. But it's just a great target. It's really cool to see this little dark lane through your telescope. Man, it's a total thrill. All right, our next target is our only newbie of the night. This is the first time we've ever done this one. And I mean, not just during an online viewing session, but I checked our cloud account where all of our images go, and no member has ever imaged this thing before. So this is a first for the remote telescope, and it's NGC 457. This should be a cool one. So NGC 457 is known as, I think most popularly, the Owl Cluster. It's also designated as Caldwell 13 in that Sir Patrick Caldwell Moore catalog, Colander 12, and Malot 7, amongst others. The Owl Cluster name is from David Eicher in the October 1980 issue of Astronomy magazine. It's hard to imagine the name is that relatively young. Classically, its more popular name is the Phi Cassiopeia cluster, because the bright star here is Phi Cassiopeiae in the constellation Cassiopeia. But this is like the ultimate Rorschach test. It has many other names. It's known as the Kachina Dow cluster, the Dragonfly cluster, the Stickman cluster, which you can kind of see in the sketch there. One I didn't know till recently is the number 5 cluster, you know, the robot from Short Circuit, but it does have another very popular name. Anybody know what it is?
ET cluster.
The ET cluster, right? ET phone home. There he is. Yes. So, and I did some research on this. It was Tom Lorenzen and Tim Schuyler referred to NGC 457 as the ET cluster in their 1987 book, 1000 Plus, the Amateur Astronomer's Field Guide to Deep Sky Observing. If you want a copy of that book, good luck. You know, again, it came out in 1987. If you look for it on Amazon, you got to pay like $135 for it, minimum. But I did a search for it recently. Some bookseller in San Diego was selling it for $77. I made an offer of $55 and they took it, so I have a copy of the book on the way. It was discovered by William Herschel on October 18th, 1787. I saw many sources online that said 1780, but as far as I can tell, those are incorrect. From most sources that I found and trust, it was found in October 1787 with his venerable 6-point-inch reflector. He described it as a brilliant cluster of bright and very faint stars, considerably rich. And many people just consider this one of the finest clusters in the sky. Here's its general location. So the great thing for a beginner is it is easy to find with binoculars. It's just off a little line toward the more crooked end of the W in Cassiopeia here. So you find Cassiopeia and you can find this cluster. And of course, here's our more detailed view with the Sky and Telescope's Pocket Sky Atlas. So we are back in familiar territory here. Over here is the Sol Nebula and the Heart Nebula with the double cluster. We should do stock 2 sometimes. I don't think we've ever imaged that before either. At all, period. See what it looks like sometime. So there we go. Again, very easy to find. About 2 degrees south-southwest of Delta Cassiopeiae, or Rockba. I guess that's how you pronounce that. And it is often overlooked due to M103 nearby, which is off the field here. But when it comes to clusters in Cassiopeia, I've always preferred NGC 7789, which is Carolyn's Rose Cluster, because it's very rich. It doesn't have the cool shape that this cluster has, but Carolyn's Rose Cluster is very, very rich. And we've done that one before during a session. All right, so this slide means we need to go back to ACP and see how we're doing. We obviously got a guide star this time. I mean, we'd be better. This thing's packed with stars in the area. And we're well on our way. And looking at the chat here, yeah, the Sombrero Galaxy is one of our favorites. We don't usually tend to get that during a online viewing session because of the time of year you have to see it, because we only do online viewing sessions from November to February once a month. By the time we get into March, we switch back to standard time, and we theoretically could start, but it wouldn't be till at least 10 o'clock. If we, for example, try to do one in July, we'd have to wait till midnight for it to get dark Eastern time. During the early days of the pandemic in June 2020, we did do one starting at midnight and went for a couple hours, but I don't think we could pull that off now. And I'm curious, and I did check the field of view of this for the 20-inch. It should really fill the cluster nicely. I'm curious to see how it'll be oriented and what's it going to look like, because I would have tried to preview this earlier this week, but the weather has stunk out there this week. I mean, it's been rotten. I don't like January. It's like the worst month of the year. It's cold and gloomy. Your shopping bill comes in the mail and you get really depressed because you spent too much money. Let's switch back here real quick, see how we're doing. So we are imaging right there. Right there is where the OWL cluster is, or the ET cluster if you prefer. Right there. And the zodiacal light has really faded away. You can see more of Canis Major now. You can even see the dog's tail. You can pretty much see the whole winter hexagon now. We got Sirius, Rigel, Aldebaran, Capella, Pollux technically, and Procyon with Betelgeuse inside. So the whole winter hexagon is now visible. Any sign of the summer triangle is long gone, which is sad. Even the Great Square is getting low. No sign of the Big Dipper yet. That's still hugging the horizon, but it's getting there. What would happen? What would have to happen for the official name to be changed to ET? None of these names are really official, at least to amateur astronomers. And of course, professional astronomers could care less. They're just more concerned with the designation you need to get your telescope there. So many sources do refer to it as the ET cluster. It just depends on the observer. I did see some European entries online that did just mention it as the Kachina Dow cluster. So maybe in different areas of the world, it's known as by different names, especially this object. Oh, there it is. Oh, wow, that's cool. Come on, come on, I'm impatient. Hurry, hurry, hurry. It's not as big as I thought. So that's good. You don't want it too big. All right, are we ready? Wait for the pop-up. I guess it's not going to pop up. Here we go. Wow.
It is bright.
Oh, yeah.
Nice.
That's really bright.
Scroll down there a bit to get it centered. I don't think there's anything. I don't see anything. Maybe a little galaxy down there. Whoops. So its estimated age is 21 million years, a lot younger than the Pleiades, with a true diameter of 46 light years. I'm assuming that's along the long way here because it's kind of a narrow cluster for the most part. It features a rich field of at least 200 stars from magnitude 9 to 13. About 60 stars have been identified as true cluster members because remember, we're looking right along the disk of the Milky Way. So many of these could be background stars, foreground stars. So it's hard to tell where the cluster ends and the Milky Way begins or vice versa. The two bright stars, Phi 1 Cassiopeae, which is this one right here, is magnitude 5. And this is a multiple star with 5 components. And the main star itself is a rare type F0 supergiant, a bright supergiant. And the other one, HG 7902, which is this one right here, is a B-type star. So this is Phi 2 as well, or the C component of the system. So there's A, there's C, and the other ones just aren't quite visible or lost in the glare here. And of course, these are the eyes of the owl or of ET or the stick man, or take your pick. And it's unclear. The main thing you read about when you read about this cluster is it's unclear if Phi Cassiopeae here, especially the bright one, is a true member of the cluster. If it is, then it would be one of the most luminous stars known. 215,000 times the luminosity of the sun, 26 times the sun's mass, 250 times its radius, because it's a supergiant. And here's the problem, though. It'd be about 6 million years old. But the cluster is only, the cluster is 21 million years old. But the star is 6 million years old. So maybe the star formed a bit later, but that doesn't make sense because the more massive stars in these areas form first, or it's just a background star or a foreground star. We really don't know. There's evidence for both. So it's very confusing when you read about it online because there's evidence it could be part of the cluster. There's evidence that it's not part of the cluster. It's very, very odd. So the two supergiants here share a similar space motion to the other stars of the cluster, which does say they have a common origin. And their Gaia data release from the Gaia probe, which is a European probe that measures parallax to measure distance and stuff, are comparable to the other stars, which is, consistent with the distance for the ET cluster here. And some say that component C here, if this is a true part of the system here, has a 70% likelihood of being a cluster member. So it gets really confusing when you read about this because the star is too young to be in this older cluster, and it's a mess. So someone needs to sort that out. They need to get their telescope and spectroscope out and do some research. But it is cool. So yeah, this is the first time I've ever done this. That's a neat one. I'm going to have to do more images of this and create a pretty color picture. All right, our last target for the night. I have to type in an alternative designation here to what I'll show you because I don't think the Barnard catalog is in here, but I could try it. And let's just we'll stick with 5 minutes. I could do H alpha, but it's not terribly impressive, really, in H alpha. So let's just go ahead and try this and see what happens. We've done this before, so I kind of have an idea. Okay, so I typed in IC 434, but the main thing we're after is Barnard 33, which is kind of the main designation for the object itself, called the Horsehead Nebula. Another target we tend to do every season, but Sometimes we do it with the plane wave like we're doing tonight. Sometimes we do it with the Takahashi where it really shows the whole area. So here's a great sketch that unfortunately I couldn't give credit because I didn't know who did it. And you can kind of see this little nub here. That's where the horse head is supposed to be. From our observatory, when we have the old 12-inch, I was able to observe the bright nebulosity in the background, which is IC 434, and we did see a gap right where the horse head would be, but I really didn't clearly see it until I went to the Winter Star Party one year and saw it through Crazy Bob Summerfield's 36-inch Dob, and it was very obvious in there, so that was cool. So, of course, it's hanging off the lower left star in Orion's belt called Al-Natak. So it's, again, very easy to find, but very difficult to observe visually. And it's located about 30 arc minutes south of Al-Natak, the big bright one there, or Zeta Orionis, which is, again, the easternmost or lower left belt of Orion. The nebula was first recorded on a photographic plate in 1888 by the Scottish astronomer Wilhelmina Fleming at Harvard College Observatory. Edward Pickering, this little gentleman here, claimed that his maid could do a better job of identifying and cataloging observatory images, and he hired his maid, Fleming, along with several other women who became known as computers. They did lots of calculations and measurements from photographic plates. And so, in addition to discovering the horse head, Fleming, who's centered here, I don't know how she breathed in that thing, but she did it somehow, discovered 58 other gaseous nebulae, 10 novae, and more than 300 variable stars. She became the first American woman to be elected as an honorary member of the Royal Society of London. It was photographed in 1894 by Edward Emerson Barnard and described it as a dark mass, diameter 4 arc minutes on nebula strip extending south from Zeta Orionis. So he made no note that the interesting part was the horse head. Let's see how we're doing here. Looks like we're still searching for a guide star. Let's peek in on the computer. Was it timed? No, it hasn't timed out yet, but it's probably going to. I don't know if this is the previous view or... No, I can't tell. Well, it's working on it. Oh, it's doing, okay, so it's doing the guiding checks. So it's getting there. Oh, and the guider is settling and we're off. All right, we're guiding. There we go. Let's look at the ET cluster again. Oh, that's so cool.
I just love how the eyes sort of stick out there.
Yep. Oh, one thing I always forget to mention is the on-axis guider always gives us a mirror image. So when you download these images later, I often forget to flip them at the end there when I do process these a little bit. So if you're comparing them with other images and it looks like it's mirror reversed, you know, or something's wrong, that means I forgot to flip it. So feel free to check on that. Because I try to get these out so fast so people can download them. I forget that it's mirror imaged. But of course, that's very easy to fix in image program. Oops, that's not the button I meant to hit, but that's okay. For a second there, I thought it ended the whole Zoom stream, but no, I didn't. Let me see. Someone asked, how large is the star? What star are you referring to, Joy? Can you tell me?
That large star in ET.
Oh, Phi Cassiopeae. It's a supergiant. a type F, so it probably gives Betelgeuse a run for its money. If you put Betelgeuse in place of the sun in the solar system, its outer layers will go out to Jupiter. So this star, which is a lot hotter, could be even a little bit bigger. So it would pretty much fill up probably out to Jupiter or even Saturn. So it's a big one if it is a supergiant. And it definitely is. That's pretty easy to determine in its spectrum. You can learn a lot from just the light from the star alone.
Thanks.
Yep, you're welcome. Well, let's go back. Oops. Oh, I still have ET open. There we go. Well, we're getting there. We're about halfway done. Yep, I don't believe any of the computers, as they were called, ever won a Nobel Prize. Probably the most significant discovery was from Henrietta Swan Leavitt, who discovered the period luminosity relationship of Cepheid variable stars, because that was extremely valuable for measuring the distances to nearby galaxies. And it really helped prove that the universe was just more than the Milky Way. Because there used to be a time we thought galaxies were just stars in the process of forming. But now we know they're tens of millions or billions, or in some cases, trillions of stars. It's crazy. Yep, I've been meaning to read The Glass Universe by Davis Sobel. I did read Galileo's Daughter years ago. I don't think I own a copy of Galileo's Daughter. I know I read it, but I don't know if I own a copy. I got a big library, so I can't keep track of it all anymore.
Got any good book recommendations in general?
Gosh, there are quite a few. You can go with some of the classics. Like if you've never read, Cosmos by Carl Sagan, I would definitely give that a read. There's Starlit Nights by Leslie Peltier. I would check that out. There's oh gosh, there's the one by Timothy Ferris years ago that had the companion PBS documentary, which for some reason the name is blanking on me right now. I have a copy of both the documentary and the book. I know Neil deGrasse Tyson's a popular author. I have some of his stuff. When we saw him speak at MSU, I bought a copy of his book on Pluto, and I'd read the whole thing while we were waiting for the lecture to begin. That's how short it is. It was a quick read.
Hey, at least it's,
Yeah.
succinct there.
Ooh, I see a horsey. $3,399 stars found. Again, you folks got to count those and confirm that for me. I'll keep you busy. Keep you out of trouble. It's processing. There we go. Are we ready for our final target of the night? Oh, now it pops up. Here we go.
Nice.
Wow.
Great.
Wow.
Oh, I see it.
Really did capture the nebula down here tonight too.
Good.
I can't get see if we can get the whole thing in there.
Very nice.
There we go. How's that? That's better. So yeah, it looks better with the luminance image than hydrogen alpha, which is unusual because usually hydrogen alpha would really make the stuff pop. So the dark nebula, which is what the Horsehead is about 3.2 light years tall, if you want to use that quote, from roughly, I think here I measured it, to here, because I couldn't find any other sources to confirm that. So I did a little trig myself. I did a little trigonometry and calculated the height that this would be for its given distance and angular diameter. And I got 3.2 light years, which is pretty comparable to, say, the pillars of creation in M16. So part of the Horsehead is part of the much larger Orion molecular cloud complex, which is composed of two giant separate molecular clouds, Orion A and Orion B. So the Horsehead is part of the Orion B complex. The background emission nebula, which makes the Horsehead possible, to be seen to be possible, was discovered on February 1st, 1786 by William Herschel, and it's illuminated by Sigma Orionis, which I don't believe is visible in the image here. And the Emission and Reflection Nebula, NGC 2023, is located to the Horsehead's lower left, 15 arc minutes to the northeast, which is right here. So this is NGC 2023. And that was also discovered by William Herschel on, get this, January 6, 1785. So today is, I don't know, do the math of the so-and-so anniversary of this object's discovery today. How about that? I had no idea. NGC 2023 is illuminated by HD 37903, which I believe is the star right there in the center, which has a spectral class of B2V. So it's a B-type star, but the V indicates it's a main sequence star. Outside the field of view is NGC 2024, the Flame Nebula, which is another emission nebula in Orion. And I believe I have that on cue to do next month, because the Flame Nebula with the plane wave is pretty awesome. So there we go, ladies and gentlemen. B33 or IC 434, the Horsehead Nebula, our final target of the night. Whoops. All righty. So a few closing comments here before I share the link for tonight for you. If you do live in one of these counties in red in Southwest Michigan, you can join the Kalamazoo Astronomical Society, pay the modest remote telescope fee as well. Just watch a short training video and read the user manual, and you too can use the remote telescope. Again, all you need is a web browser. It's really easy to do. And you also have access to every image the telescope has ever taken. So our next online viewing session is on February 3rd, weather permitting. So let me put the registration in the chat here. Usually have someone to help me with this, but there's no one that signed up to help me. So there's the URL to register for next month's online viewing session. So again, it's February 3rd with a cloud date of February 10th, but so far, this is our third session this season. We have not needed the cloud date, so this season's going much better than the last one, where we had all kinds of technical issues and cloud issues, and it was just awful. So if you are not a member of the Kalamazoo Astronomical Society, and you're not on there already, you can sign up to join the online viewing session email list. We only send out maybe half a dozen emails between November and February, so you hardly ever hear from us. And you basically get reminders about the sessions coming up, registration and YouTube links. Right now, we haven't been putting them on YouTube because we have expanded capacity on Zoom as part of the Eclipse series, so it hasn't been necessary. We'll give you the link to download the images, which I will do here shortly, but it's better when you have it and reserve on your email. And of course, if we do have to postpone or cancel, you'll get notification of that as well. You can use our contact form. Make sure you select you want to join the viewing list, or you can just send us an email at kas@kasonline.org. And I already mentioned this already. Our Eclipse series is ongoing. The 4th installment is this coming Friday on January 12th at 7 o'clock Eastern time, to be precise. And we have none other than Jay Anderson, very well-known Canadian meteorologist, author, and eclipse chaser. He's been to 33 total solar eclipses to date. And he'll be joining us here in Kalamazoo. So we want to have a strong attendance for his appearance here in Kalamazoo. But if you do live out of state, it will also be live streamed on Zoom. Sorry, I'm doing things here in the background here. And also, along with the link for the Eclipse series, the Introduction to Amateur Astronomy lecture series begins the following day on January 13th. And I'm so glad we don't have the cloud session that day, because that'd be a lot for one day. And you can register at the link provided in the chat, or just go to our website, kasonline.org. And as mentioned, we already have 600 people that have registered from around the world. And I do mean, like I mentioned earlier, around the world. The Eclipse series continues on January 19th. If you are interested in astrophotography, but you want to watch the eclipse and not your camera, then definitely register and join us. We have Fred Bruinges and Xavier Jubier. I'll work on those pronunciations. They'll be demonstrating the software they've developed to automatically photograph eclipses. Fred developed Eclipse Orchestrator for the PC, while Xavier developed Solar Eclipse Maestro for the Mac. So they'll show us how to set up their program so your camera hooked up to a laptop can take images of the eclipse while you're just watching it. I've used Eclipse Orchestrator twice now, and it has worked flawlessly both times. And we continue with the Eclipse series on February 2nd. If you've ever visited greatamericaneclipse.com, that's put together by the cartographer Michael Zeller, who's also an avid eclipse chaser, and he will also be joining us here in Kalamazoo. So we are getting ready for the total solar eclipse on April 8th, 2024. If you don't have them already, you can order eclipse shades from us at the Sky Shop. I'll pop the chat, or I'll pop the link to order those in the chat as well. And remember, when you do purchase these from the Kalamazoo Astronomical Society, you do support stuff like the remote telescope and online viewing sessions, because we can use a lot of the proceeds from this to help upgrade the cameras, for example. So we do put that money to good use. So don't buy it from some profit business or even a museum, because they get tax dollars and endowments. We get basically very, very modest member dues and the occasional donation. So buy eclipse shades from us, or at least another astronomy club, for goodness sake. So here's the link to download tonight's images. I will pop it in the chat. But if you are a member, or you're on the online viewing session email list, you have this already. So I know that's a lot of links, but there you go. We're very busy as of late, so there's a lot going on. So there's the link to the images. Of course, don't hit that link now, because we just took the things. So I got to download them. I got to process them. It might be till Monday before they're online, but there's not a whole lot going on at the moment right now for me. So I should be able to get to them maybe even tonight, or most likely tomorrow afternoon. So by Sunday evening, I'm hoping to have them online. But if they're not there, wait till Monday. Then by maybe late Monday or Tuesday, then you can start harassing me. Richard, where are the images? Where are the images? Well, just wait. I'll get there. So if there's nothing else, thank you everyone for joining us for the January 2024 online viewing session.